Hello everyone, this is the 2022 Winter Week 8 Day 1 solution video. Problem 1. Fill the missing numbers in the blank. For the first equation, we see that something with a 4 in the units digit plus 53 is equal to 77. Let's start off on the left. We know that 4 plus 3 is equal to 7, so there's no need to carry. So therefore, we know that a number plus 5 equals to 7. Well, that just gives us 24. So 24 plus 53 is equivalent to 77. Next, 20-something plus something with a 6 in the units digit is equal to 91. And since we know that 6 is larger than 1, we know that something plus 6 has to be equivalent to 11. So therefore, that is nothing other than 5. And then we have to carry over a 1 over here. So therefore, 2 becomes 3. And so something plus 3 is equivalent to 9. That just gives us 6. Because 6 plus 3 plus 1 is equal to 9. So the second equation is 25 plus 66 is 91. Third problem, 68 minus 30-something is equivalent to 35. Well, we know that 8 minus 3 is 5. And since there's nothing on the left we have to do, we just get that 68 minus 33 is 35. And finally, for the last problem, since 6 is again larger than 5, then we know that the top number instead should be 11. We carry over the 1 here, and 7 becomes 6 since we carried over. So 11 minus 6 is, of course, 5. But then 7 becomes 6, so 6 minus something equals to 2. That just gives us 4. So 71 minus 46 is 25. And this is how you should do problem 1. Problem 2. Which of the following numbers is different from the others? Well, upon looking at this pattern, we notice something. All of these numbers are even except 1. So O is for odd and E is for even. So 6 is even, 8 is even, 10 is even, 21 is odd, and 32 is even, 46 is even, and 74 is even. So all of these are even numbers except 21, which is odd. So therefore 21 is different from the others. And the second part of the problem, which of the following 4 cards are different from the others? Well, looking at this first card, each time a number is changed, it goes up by 3, by 3, by 3. And looking at the second pair of cards, it's also by 3. However, upon looking at this third one, we see that it goes up by 2 instead. Whereas on the fourth one, it's again goes up by 3. So therefore, the third one is different from the others because it's increasing by 2 every time instead of 3. If a star minus a square is equivalent to a star, then star plus star plus star plus square is equal to 12. Find the star and square. So as we can see in the first equation, this star is exactly equivalent to the star as a result. So therefore, we know that the square has no impact on this equation whatsoever. So therefore, we know that it must be 0 because anything subtracted from 0 is equivalent to itself. Because if we put the square as anything, for example, 1, then that wouldn't result in the same thing as we subtracted it from. So therefore, we know that the square must be 0. And if the square is equal to 0, then we can plug it into the second equation, which is 3 stars plus 0 equals to 12. And from there, we can just conclude that 1 star is equal to 4. So therefore, over here, a star is equal to 4, and a square is equal to 0. Problem 4. Jeff bought several basketballs and soccer balls from a sports shop. In total, he paid $90. If each basketball cost $20 and each soccer ball cost $15, how many basketballs did he buy? So for this problem, all we have to do is guess and check and play around with the numbers, and eventually you should have gotten he bought 3 basketballs and 2 soccer balls. And let's draw it out to see if we're correct. If we bought 3 basketballs and each are equivalent to $20, this in total is $60 or equal to 3 basketballs. And then let's see for soccer balls, if we bought 2 soccer balls, each soccer ball is $15. That's just $30 equals to 2 soccer balls. And then up here, we notice that 60 from the basketballs plus $30 from the soccer balls is equivalent to $90, which is exactly in total what he paid. So the answer is 3 basketballs and 2 soccer balls. This is the Winter Week 8 Day 2 solution video. Problem 1. 5 boys competed in a shooting challenge. Ricky scored the most points. Which target was Ricky's? So let's look at the first one first. So a number inscribed inside a circle means that that's the points which represent these circles. Let's look at the first one. We see that there is a circle inside the tens point, so that means that they scored 10 points here. And then we see that there is a circle inscribed inside a circle with 8, so he scored 8 points here. And there's a circle inscribed in 7, so someone scored 7 here. So in total, it's 10 points plus 8 points plus 7 points. That just gives you 25 points for number 8. And now let's look at B. This time, this person scored another 10 points inside the 10 pointer. And this time he shot 2 times inside the 7. So 7 on both sides. And this time it's 10 points plus 7 plus 7. It just gives you 24 points. And looking at C, this time there are three points both inside the 8. So it's 8, 8, and 8. So in total, there are 3 8 someone shot, and this is also 24 points. And looking at D, this person shot 1 time inside the 8 circle and 2 times inside the 7 circle. So it's 7 plus 8 is equal to 22 points. And finally, E, this time, this person scored 2 times inside the 9, so it's 9 and 9, and 1 time inside the 8, so it's 8. So 9 plus 8, that just gives you 26 points. And looking at all of these, we can see that the most points shot were inside E, and it says that Ricky scored the most points, so therefore we know that Ricky must have scored E. Problem 2. Mr. Lee has raised several chickens for egg production in his backyard. During the past several days, his chicken has produced 36 eggs. How many egg cartons as follows does he need to contain those eggs? So as we can see from the picture, each egg carton can contain 10 eggs. Because look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is equal to 10 eggs. And as stated above, he has produced 36. So let's see. If we can divide 36 into 30 eggs plus 6 eggs, and since each carton has 10 eggs, we can store 30 of them into 3 cartons of 10, 10, and 10 equals to 3 cartons. However, he has 6 left over, and since he can't store literally any more inside these 3 cartons, he needs an extra one to store these 6 eggs. So 30 plus 6 is equivalent to 3 cartons plus 1 carton more, and that just gives us 4 cartons. So the answer is 4 cartons. He needs 4 cartons to store 36 eggs. Problem 3. 2 good friends, Benjamin and Xavier, play chess for 20 minutes. If the clock below shows the time they finished playing, when did they start to play? So from this clock, we can derive that the time is 11:11. And it says that they played chess for 20 minutes, and after they played for 20 minutes, the time is 11:11. So therefore, we need to subtract 20 minutes from 11:11. And we can break 20 into 11 minutes plus 9 minutes. So let's subtract 11 minutes from the time first, and that just gives us 11 o'clock. And we still need to subtract 9 minutes from 11 o'clock. So 11 o'clock minus 9, that just gives us 10:51, because 1 hour has 60 minutes. And if you subtract 9 from there, that also gives you 51 minutes remaining. So therefore, the time that they started playing is 10:51. And you can double check this by adding 20 more minutes to it, and that still gives you 1111. So the answer is 1051. Problem 4. How many cubes do we need to build the following three-dimensional figure? How to calculate this is let's count up the cubes first. We have one right here in the back, one right here, and one right here. So on the top, there are 4 cubes. But at the bottom, it's a little bit more tricky. We have 2 rows of 3 cubes, as we can see here. So in the green, that's 2 rows. And in the red, this is 3 cubes in each row. So 2 rows of 3 cubes, let's write that out. 2 rows of 3 cubes, that just gives us 6 cubes. So in total, on the bottom, let's write it in green here, equals to 6 cubes. And then 4 plus 6 is equal to 10 cubes. So for problem 4, the answer is 10 cubes in order to build the following three-dimensional figure. Day 3, problem 1. If a circle minus 21 is equivalent to a diamond plus 18, then a circle equals to a diamond plus what? So right here, we have 2 methods. Let's try out method 1 first, which is to plug in special numbers or try special numbers. So let's start off, for example, let's do diamond is equivalent to 0. Then a circle minus 21 equals to 0 plus 18 equals to 18. Then a circle equals to 21 plus 18 equals to 39. Therefore, the answer is 39. And now let's try out method 2, which is a more straightforward algorithm on how to solve this. A circle minus 21 equals to diamond plus 18. Then a circle minus 21 plus 21, and this just cancels out with each other, is equivalent to a diamond plus 18 plus 21, and this just gives us circle equals to diamond plus 39. So again, 39 should be your answer. So the answer is 39 for problem 1. Problem 2. Dan went to a coffee shop to buy a cup of coffee and a cookie. The coffee was $2.35 and the cookie was $1.50. If Dan gave a $5 bill to the cashier, how much did he get in change? The coffee is $2.35, while the cookie is $1.50. These two together, let's find the sum of these together. That just gives us $3.85. And if he gave the cashier a $5 bill, we just need to subtract the $5 from the actual value of these items. So 5 minus $3.85, and that just gives us $1.15 in change. So the answer is $1.15. Problem 3. Peter chose a square of 4 cells in the table so that the sum of the 4 numbers inside the square is greater than 63. Which of the following numbers must be in the chosen square? Number 1, 14, number 2, 15, number 3, 17, number 4, 18, and number 5, 20. We can see and play around with squares until we get 2 squares that is either greater than 63. For example, this square highlighted in red, 13, and let me write it out. 13 plus 14 plus 18 plus 19 is equivalent to 64, which is greater than 63. And the second square in green is over here, which is 14 plus 15 plus 19 plus 20, and that gives us 68, which is also greater than 63. And as we can see, 14 and 19 are the only common ones, common numbers. And let's see here. Since there's no 19, then we know that the answer must be 14 because that's the only common number inside both of them that is still included in the choices below. So we circle 14, and that gives us that the answer is A, or 14. Problem 4. There are 5 blocks of different colors stacked on top of each other. The red block is above the purple block, the blue block is underneath the orange block, and the green block is below the blue and above the red. Which color is the bottom block? So first of all, let's have the greater than sign equal to above. So let's label all of these out. So first we have that red is above purple, orange is above blue, green is above red, and finally blue is above green. So after you match all of these up and sort of play around with the numbers, you should get the following sequence. Orange is the top color, which is higher than blue, and blue is above green, and then green is above red, and finally red is above purple. And from here, we can see that purple is the lowest color here, so the answer is purple. So for this problem, you just had to label out the information that you have and sort of just play around with it until you find a sequence that matches. Day 4, problem 1. Benjamin has to finish his homework before he can play the game Plants vs. Zombies. Also, he needs to go to bed by 8:30 p.m. If it takes him 27 minutes to do his homework, what is the latest time he can start his homework and still play the game for at least 15 minutes? So first of all, if he has to go to bed at 8:30 p.m. and play the game at least 15 minutes, then we have to go back 15 minutes and he has to start playing the game by 8:15 p.m. And then the latest he can do his homework is 27 minutes earlier. So go back 27 minutes. Well, we can break down 27 minutes into 15 plus 12 minutes. Let's go back 15 minutes first. And go back 15 minutes, that's just 8 p.m. And then subtract another 12 minutes to complete the 27 minutes, and that just gives us 7:48 p.m. So the latest he can do his homework is 7:48 p.m. is our answer. Problem 2. Sarah has 13 blue marbles. She can trade marbles in 2 ways. 3 blue marbles for 1 red marble, or 2 red marbles for 3 green marbles. What is the maximum number of green marbles she can get? So we need to try to trade as much blue marbles for red marbles as we can because we need to get green marbles, and that can only be traded from red marbles. So let's see. Let's pretend that black is blue here. So let's just draw out 13 blue marbles. Okay, and this is 13 blue marbles, so-called blue marbles. And it says 3 blue marbles for 1 red marble. So let's group up 3 blue marbles all together. So as you can see here, we have grouped together 4 groups of 3 blue marbles with 1 left over. So this can be 1 red, 1 red, 1 red, 1 red. And this together is 4 red marbles. And then it says, let's just draw these 1 red by red marble. Okay. And it says 2 red marbles for 3 green marbles. So let's pair up 2 of these equals to a 3 green. And this 3 green. And this just gives us 6 green marbles. So the answer is 6 green. That's the maximum. Next problem. 48 people are divided into 3 groups with different numbers of people. If the numbers of people in each group all have unit digit 6, what are these 3 numbers? So let's just write all of these out. 6, 16, 26. Let's write some of these out. 36, 46, 56, 66, so on. These are just some. And let's cross out the ones that we know cannot work. Because it says 48 people, we can cross out, for example, 66 and 56 since that's larger than 48. And we can play around with the numbers. And eventually you should get the 3 numbers that can add up to 48, and that is just 6, 16, and 26. Problem 4. Mary randomly selected N students from Turtle Rock Elementary School. What is the smallest value of N to ensure that at least two of them were born in the same month? So let's just pretend that Mary chose the most number of students in the most unlucky way. Well, as we can see, we have the months written on the bottom here, and let's just say that she picked one for each month. For example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 students with each born in another month. So 12 students. However, what is the smallest value of n to ensure that at least two of them were born in the same month? Well, to make sure 100% that there are at least two of them, we need to randomly select another student because no matter what month this student is born in, it has to be in one of these months. So let's just pretend that he is born in August. And then so to ensure that at least two of them were born in the same month, 12 students plus one student equals to 13 students. 13 students is our answer. Day 5, problem 1. Students in Mr. Smith's class stand in 5 lines for group exercise. Each line has the same number of people. Jack, one of the students, find that there are 2 people in front of him and 3 people behind him in his line. How many students are in Mr. Smith's class? So let's pretend that this little red dot is Jack. And it says that, let's pretend that the top is behind. So it says that there are 3 people behind him in this line. So let's just pretend that the blacks represent 1 person behind him. So there are 3 people behind him. And there are also 2 people in front of him. So let's draw 2 black dots. And let's count these dots up. And there are 6 people in each line. And it says that each line has the same number of people. And as we have just counted, there are 6 dots in each line. And there are 5 lines, then it's just 6 plus 6 plus 6 plus 6 plus 6 equals to 30 people in Mr. Smith's class. So in total, there are 30 people in Mr. Smith's class. Problem 2. Which of the following stories could match this number sentence? 14 minus 7 plus 9 equals to 16. So just as a heads up, minus is equal to 8. While add, the addition is equal to receive, or he got. So looking down at these, we can eventually find out that the answer is C because it matches all of the criteria. Lan had 14 lollies at the beginning, which is correct. She ate 7 of them, which is also correct since it's subtracting 7. Then was given 9 more by her mother, which is also correct since she received 9 from her mom. And she now has 16 lollies, which is the answer. So therefore, the answer is C. Problem 3. Find numbers A and B. For number 1, BA plus A9 equals to 71. So because we know that 9 is larger than 1 first, let's look at the first question on the left-hand side. We know that A must be 2. And the bottom should be carried over, 1 should be carried over. And since we derived that A equals to 2, then 2 must also be at the bottom here since it's the exact same. And this time, for the carried over 1, 2 plus 1 equals 3, and something plus 3 equals 7, well, that just gives us 4. So this one should be 42 plus 29, and that gives us 71. For the second equation, A3 minus BA is equivalent to 25. And since 5 is larger than 3, we know that this 3 should be 13. And 13 minus 8 is 5. So therefore, we know that A is 8. And 8 is carried over here. And 8 minus something is equal to 2 because 3 was 13. It borrowed a 1 from 8. So instead of just being 8, let's put it to 7. So 7 minus something equals to 2. Well, that's easy. That just gives us 5. So 83 minus 58 equals to 25. Problem 4. A student has some sticks of length 5 centimeters and width 1 centimeter. With the sticks, he constructed the fence below. What is the length of the fence? So first of all, it gives us the length of one stick, which is 5 centimeters, and the height, which is 1 centimeter, or width. So from here, we can solve that this part is 1, this part is 1, this part is 1, this part is 1. And also this part is 1, this part is 1, this part is 1, and this part is 1. Okay, So let's see here. First, we can see that the sides of this, of course, is 4, because as we can see, each length should be 5, but because this is overlapped by this 1, then it's just 5 minus 1 is equivalent to 4, so it's 4 over here. So 4. And for the next one, we don't have to solve anything. We just know that this is supposed to be 5 since the length of this is 5. So this is 5. And then we have to solve the middle part. Well, we know that this should be 5 subtracted from 1 right here, subtracted by another 1 since it's overlapped by here, and this gives us 3. So the length of this part is 3. And next, we again see that this is 5. So this is 5 because the length is 5. And finally, we have this, which is basically 5 minus 1, since this part is overlapped, equals to 4. The length is 4 for this part. So in total, it's 4 plus 5 plus 3 plus 5 plus 4. And in total, let's see what this gives us. And this is just 21. Okay, and the answer for problem 4 should be 21 because we have just solved it.